Good day, Assessor. My name is Moses Ramaslela, and today I'm reflecting on my ICT Integrated Grade 3 Mathematics lesson, which is focused on fractions. The specific context covers unit fractions, specifically halves, thirds, quarters, and eighths. To align this lesson with Bloom's taxonomy, I established three distinctive objectives. Firstly, at the understanding levels, learners have to identify and write unit fractions from shaded geometric shapes. Secondly, to apply this, they would have to physically partition whole shapes using interactive manipulators, PHET, simulation tools to be specific. Thirdly, they'll have to analyze this. They compare visual unit fractions to determine which portion represents a larger share. Implementation of this lesson phases and SAMR levels would go like this. During the introduction phase, I displayed a scenario of a pizza, a whole pizza being divided among different amounts of people. We share it among 3 people, among 4 people, and we'll see how many shapes are then left. Then we can see how we add and subtract from fractions. A Mentimeter prompting learners to click which share would be larger, a half or a quarter. We display this model on a projector and digital tools during the classroom with learners using the tablets. The digital poll simply substituted a traditional paper check or show of hands within an identical digital option, though it did offer real-time visual results. Learners were able to mark themselves or assess their own work. And during the development phase, I moved from abstract numbers to a concrete conceptual space using the Mathigon polypad. Now, learners drag, snapped, or color-coded fractions to build one whole unit out of unit pieces. They would take out the whole pizza and then they would feed, and then they would be able to feed 3, or the pizza would be divided amongst maybe 8 or 10 pieces, and then the learners would carry on with those work. Now, this activity achieves the modification level on the SAMR spectrum. The digital platform modifies the task significantly because virtual fraction tasks allow for instant resizing, perfect shaping, and visual overlays that physical blocks cannot replicate, completely transforming how learners manipulate the shapes. Because we usually use bricks and shapes that are physical to touch, we cannot conform them to numeric shapes whenever we deem to. So this digital tool actually helped a lot. Now, for the consolidation phase, I hosted a gamified 5-question fraction matching quiz using Kahoot. Learners analyzed geometric diagrams on the main board and matched them to numeric fractions using under a time limit. I classify this as at the augmentation level of SAMR. The tool acts as a direct substitute for a multiple choice quiz, but it significantly augments the learning experience by embedding game mechanics, a competitive timer, and instant corrective feedback loops. Now, the teacher roles and the inclusive teaching part reflects most on our roles. My action as the teacher was to facilitate, model the digital applications on the smart board, and monitor group dynamics. The learners were active participants rather than passive learners, driving their own discovery by manipulating the virtual blocks that I talked about earlier. To ensure inclusive teaching, the visual and spatial nature of the digital fraction walls provided excellent differentiation support for struggling learners who have difficulty reading abstract symbols. Because we couldn't use shapes like squares, hexagons, and whatnot. A pizza was the best shape for these learners. Now, most learners can actually see other shapes. So for them, I accommodated them by expanding the sandbox environment to experiment with combining fractions. That means we can combine 1/8 and 1/6, or we can say 1/6 of 29, and we were able to decipher the fractions. Now, for critical reflections and effectiveness of the program, the IC tools successfully transformed abstract numbers into interactive, concrete visualizations. However, for practical improvement, um, we would need a clearer classroom routine for distributing and logging onto the devices to save valuable instructional time, because most of the students wouldn't have tablets. We still have load shedding. We still have many hurdles in our classrooms today. So that would be to stop students